We can picture pyrolysis in this way. We put biomass in, we heat this biomass by adding heat, and the products are basically char, which is going to be used for later energy uses or to be buried as a soil amender. And we also have gas and tar, which can be used as a source of energy for heating the process. And the reaction is characterized by several parameters like reaction, temperature, pressure, residence times, heating rate, etc. The objective of the project is to maximize char yields for two alternatives. One of them is for making charcoal for energy uses, and the second one is making biochar to be used as soil amender. The difference between these two is that biochar, when used for soil amender, needs to have certain properties, especially regarding specific surface area per kilogram of biochar, and that parameter peaks at 470 to 500 Celsius degrees. So creates a constraint for the peak reaction of peak temperature of the process. And one constraint that we focused in is having no requirement of external energy in order to be the process self-sustained in energy terms. In terms of moisture content, it doesn't have a big impact on the process yield and the process energy consumption. The big impact it has is that if the moisture content is too high, the process is going to take more energy. However, several sources say that the optimal moisture content for biomass is 10%. Regarding particle size, long residence times and low heating rate allow us to use particles in a couple of centimeters time without constraining the process for heat transfer or moisture transfer phenomena. Okay? So we are focusing on particles roughly a couple of centimeters in radius.
I'm going to take at the biochar touch. So you discussed the preferred temperature, and for charcoal you said the lowest temperature because you get the highest yield, which I would agree with. And for biochar you said 500 would be optimal, assuming that this is where we get the best properties.
Yeah.
One of the things you didn't mention, which could be interesting or could have an impact on this, although it might give you the same answer, is the fixed carbon content. Because biochar is meant to be
to fix carbon.
Yeah. It is meant to, be a climate change tool or whatever. And basically what happens is that the total yield of char is higher at lower temperatures, but there's more volatiles in it, which means the fixed carbon content is lower. And so that may be something interesting to mention in your dissertation, is that you might want to go to a higher temperature because you'll actually have more or the same amount of stable char.
Yeah, and in terms of biochar, I did some calculations, and I looked at a couple of sources reporting different values, but it has higher fixed carbon content, but at the same time the yields start to decrease, so it kind of compensate, and it's necessary to have a detailed assessment for each process, I think, and each biomass type to see what's the optimal. This is just general conditions, has to be specifically calibrated for each biomass type and each kiln used to get to the optimal point.
Okay, yeah, well, I was basically suggesting that it would be good to have a short
That's
an important thing. And then you mentioned surface area as the key parameter. And I would argue that that's probably a very important one, but I think there's also a lot of other ones.
Yeah, the thing is that it's because of the thermal behavior of surface area, because the other parameters are important as well. But what I saw was that the other parameters had a softer behavior with temperature. They change more softly. But in terms of surface area, it was really low until 400 and some degrees Celsius, and then it peaked really fast over at a certain temperature. That's why it's not the most important parameter for biochar probably, but it's the one that changes the most with temperature, making it the bottleneck for choosing biochar temperature.